Hello everyone and welcome to another video. Last week I found a steal of a deal posted on the local Craigslist for an older gaming PC. The GPU is a few generations old and the CPU is now 7 generations old. It has all the marks of a 2019 PC. In the YouTube tech sphere, this might sound like a bad thing, but a system like this is really capable. I'll show you. Before I show you the benchmarks, I just wanted to say that the FPS numbers you'll see on the MSI Afterburner overlay might be leftovers from a previous benchmark. I forgot to clear them a lot. The key things to pay attention to are the frame time graphs and the utilization numbers, so we can see stutters, spikes, potential bottlenecks, and things like that. Also, recording adds about 5 to 10% to the frame times, or reduces frame rates by a similar amount. Final Fantasy VII Rebirth is one of my favorite games to test because of the hit of nostalgia I feel every time I open it up. It's also a very demanding game that can use a lot of VRAM. In Calm, which is one of the earliest towns you'll visit in the game, I benchmarked by making a quick loop from Tifa in the town center, through a crowd shopping at some stalls, down a street at one of the upper levels, and then back down the stairs to Tifa. It was probably the most consistent way to test the game without giving spoilers or trying to somehow make combat the same across every benchmark run. This is about a 1-minute run, and I've seen examples of the game running gradually out of VRAM over time and then stuttering a lot more, which could still happen. But after messing around with the settings, I think I found a pretty safe way to play and keep consistent results. At 1440p with no scaling and max settings, the computer couldn't reach anything close to 60 frames per second. At 66% scaling and 50% scaling, with DLSS 4 also, the smoothness improved but still didn't get up to 60 frames per second. Starting with the highest preset, I then turned down the background models from ultra to high, textures from high to medium, and shadows from high to low. That got it past 60 frames per second at 50% resolution scaling. At that point, the game's basically running at 720p, and DLSS 4 is doing all of the heavy lifting. But that's not a big problem, really. I think the game looked better still than the base PS5 did in performance mode. And don't get me wrong, I still think that was a great way to play. It looked fine to me, just not as sharp as the high resolution mode, but it was still a very enjoyable game, even playing like that. Monster Hunter Wilds is another recent game that's overly demanding, but doesn't really require the highest frame rates to enjoy it. I used the recommended preset that the game started with. I don't know if the NVIDIA app supplied that or if the game did, but I'm scrolling through it on screen now. This is another game that beats up an 8GB card if you crank the settings to maximum, but doing that won't necessarily make you enjoy the game more. The system scored 16605 on the benchmark and averaged 48.61 frames per second at 1440p with these settings. Not bad. In Control, I did my usual hallway run at 1440p, but with DLSS 4 enabled and resolution scaling, so it wasn't true 1440p. High settings were used for both the rasterization settings and the ray tracing settings, the high presets I mean. The computer played above 60 frames per second on average, which is pretty impressive. Combat in Control isn't as tight or twitchy as like a competitive first-person shooter, so you could get away with 60 frames per second or even lower if you can tolerate the choppiness. Playing without ray tracing would be a good way to get much more frame rate out of this game. I also tried Deathloop and Death Stranding, since they're both recent console titles, not because they both say death. I forgot to record Deathloop, but both games were surprisingly consistent and played really well on this system. It's amazing how good Death Stranding runs, actually. It was very smooth at maximum settings, 1440p, and no scaling. In Tekken 8 at 1440p maximum settings and no scaling, it seemed playable, but it fell short of a constant 60 frames per second, which all fighting game players are going to want. Turning DLSS on to quality felt much better, but there were still some noticeable spikes. DLSS balanced to even things out even more, and that's probably how I would play it. The in-game FPS counter in Tekken 8 doesn't show or detect a lot of the spikes that Afterburner picks up, and some of those spikes are from scene transitions or in parts of animations where the game becomes uncontrollable, meaning your inputs don't matter. So they're not a big deal, but I think I would still prefer a more smooth and even frame rate, which is why I would go with the DLSS option. Street Fighter 6 was much the same. You can get a constant 60 frames per second out of this system just by turning a few graphical settings down. Things like ambient occlusion or subsurface scattering, that kind of thing. At 1440p maximum, it would drop below 60 frames per second in some non-game breaking ways, but if I turned off those other settings, I could get closer to a consistent 60 or just an actual consistent 60. 1080p fighting game players shouldn't have any problems with a system like this. The Final Fantasy XIV Dawn Trail benchmark is a pretty good tool at simulating various situations in that game. The first scene is a very closed-off cutscene. The second is an open-world solo situation. The third scene is probably the most demanding, especially for the CPU, because it has a lot of characters in open-world combat and a ton of on-screen effects. The fourth scene is a city cutscene with a lot of NPCs and characters moving around, and the final one is a good representation of dungeon and raid performance. At 1440p maximum settings, with DLSS scaling always enabled, the system was totally playable in every scenario. Even the open world combat scene, where the CPU is pushed the hardest, and this is an older CPU, the game still held up above 60 frames per second on average. The raid scene towards the end pushed 141 frames per second on average, which is a great result too. I actually recommend locking this game to 60 frames per second for the immersion factor, because some things like cloth physics or the rabbit ears on the Vieira characters can break and they become rigid. It looks kind of weird, especially there are some cutscenes where like a villain's clothes will turn stiff and it just looks hilarious. This game is a great candidate for frame generation to add smoothness, and since input delay and lag in general is part of the MMO experience, and the lag from frame generation is probably going to be a tiny fraction of the total lag you feel when controlling your character. And it would make the animations more smooth without breaking the physics, the frame generation would. That said, I don't think you can get frame generation on a 20 series card unless you use something like lossless scaling. The last game I'll test is probably the most important game of the last decade. Uma Musume Pretty Derby ran perfectly on this system, and I can't imagine any Uma Musume Pretty Derby player feeling like they're at a competitive disadvantage because of a system like this. Alright, the benchmarks are done. Now I'll tell you that the guy who listed this for sale, who knew exactly what he had and what he was posting, and just wanted it out of the house quickly, posted it for just $125. At that price, it's an insane deal. $125 for a system like this that can get you into 99% of modern games and like everything else before that is just incredible. I'd say even at something like $350, a computer with these specs would be a great value. I know it's easy to get caught up in like the new shiniest thing, but if you have a computer like this, I think you could be really happy with it playing current games. And I wouldn't really worry about upgrading until it's going to make a giant, meaningful difference to the gameplay. I think that might come in the next generation of GPUs, where high VRAM and path tracing and all that kind of thing is really going to start to be a standard. That's my prediction anyway. Thanks for watching, and come back for the next one when I put an RTX 5060 Ti in this and see how it scales with a more recent GPU.